So in this problem, where's my pen? There it is, right? In this problem, it's going to go, it's launched at an angle of 25 degrees, and it's 29.9 meters per second. We want to know how far it goes, right? What this distance is. That's called the range, the horizontal distance, before it hits the ground. We want to know what time it's in the air, right? The total hang time. We want to know what's its speed at the highest point. We want to know what the height of it is. How high does it go? The greatest height, everything, right? And the very good news is this, is that we can solve this thing using this, like we've always been doing. It's just that we got to do something before we can do this. Yeah? There's something we got to do. We got to do some important vector thing before we can actually go off into X and Y land. Okay? So who knows something that we know? 9.8 is what? Is what? Vertically. No, this isn't going to be zero. Because we're always talking about right after it's launched and right before it hits the ground. What else do we know? Horizontal acceleration 0, and this is golden. Every single projectile motion problem ever made has that. That is correct, right? And if it isn't that way, then it's probably not projectile motion, it's something else. Okay? Or you're on a different planet. Gray's got something. Between the moment he thought to raise his hand and... Is it what? 29.9. Is the vertical velocity 29.9? No, this velocity is at some angle, so not all of it is vertical. I see the minds working. The gears are turning. The gears are turning. The horizontal velocity, well, the 29.9 is not all horizontal either, is it? So if only there was a way to take the 29.9 and figure out how much of it is horizontal and how much of it is vertical. If only there was a way to do that. Is there a way? What is the way? I've already told you. What do we do? Durant's got something. Does that have something to do with sine and cosine? Yeah. What do we do? Change it to vector commas. Very nice. Yeah. So I'm going to find the x and y components. The x component is going to be 29.9 cos 25. And the vertical is going to be 29.9 sine. Those are 9s. So 27.0, what is it, 099 or something like that? There you go. Right? And what's this guy here? Okay. No, I think it's right. So take your calculator and go 29.9 cos 25. You should get 27.099. And there's nothing else to do, by the way. Just take your calculator out and calculate along with me. Yeah. 12. Oh, try 29.9 sine 25. Try that. Those are just components. We should already know how to do that, but maybe we forgot.
We just go really fast.
Yeah, we're smart. We're just... No, I'm smart too. Are we good? Has everybody gotten these components? So now we know for this initial launch velocity how much is horizontal, how much is vertical. So what should we do with those?
So that's the initial.
Yes, it is. Right? So what's my initial horizontal? And what's my initial vertical? Okay, so now I shouldn't have to like show you anymore, but I'm gonna, because I'm just like a teacher. I'm just gonna like show you, right? Okay, so this is the only trick, if I can interrupt. This is the only trick really for this one, and then we could just solve it. Okay, but there are a few more tricks to show you, right? But you just break the launch velocities. If they're not purely horizontal, if they're vertical, they're stupid, right? That's just linear kinematics. If they're horizontal, then you don't have to break it into components. But if it's at some angle, then we break it into x and we break it into y with sine and cosine, or cosine and sine. Tyler's got a question.
It's a question about the calculator and its functions.
Yeah.
Related to this.
Yeah.
The vector calculator on your TI-84 Plus.
Uh-huh.
How do you use that?
I don't even know how to use it. I saw that in there the other day.
I won't learn.
I know. They gave you a book on how to do it, so, you know. Okay, so now let me just show you the other trick. Okay, here's trick number one. This thing goes up and it comes down. Doesn't it end at the same level that it started? Yes, so the vertical problem, that was a special kind of vertical problem. Guys, hello? That was a special kind of vertical problem. What is true about this final velocity? Same as the initial, only negative, correct? Okay, so this guy is negative 12.636, and that I'm going to put a little warning on that. That's if it's level. Most of our problems with arc trajectories will be they'll land on a level surface, right? So if and only if it's level, that's true. You can just say it's negative that. We also, by the way, know that this is zero. The net vertical change in position is zero. So we started and ended at the same elevation, didn't we? Yeah. Okay. So now we're all set. We know actually everything but time. We can probably find time on this side. Put time across. Yep, this time will go across. We know this guy is 27.099, right, don't we? Because it's the same as this guy. These guys are always the same. Vertical distance is zero because it's not distance, it's displacement. It's a change in position. So it started and ended at the same elevation, right? Okay. So now we're set. I'm gonna find time using VF as VI plus. Yeah. Okay. That's my favorite one. So negative 12.636 is 12.636 plus negative 9.8 times t. So take your calculator right now, every man, woman, and child, and touch it in such a way as to get the answer for t. Now, if you get 0, by the way, for the answer, your math teacher is going to experience a sharp and unexplainable pain in their abdomen. It's not 0.
Whatever.
Someone's kind of actually easy to do.
Well, no. You're going to subtract 12.636 on this side and get negative 25.2, blah, blah, blah. Yeah, it's going to come down. It's always negative if it's level, and it's always negative exactly what that is. If it's level, right? Now, if they give you some other problem, like you're going to shoot it up onto a cliff or something like that, right? Then that wouldn't be true. Or if we're talking about like some other place besides the ground, then it wouldn't be true. But for the simplest one, that's always true. Okay. Do you guys get something like 2.5787? I mean, I'm going to say 88 or something like that. 578 is good enough, right? Notice that I'm carrying a bunch of digits along with it. And the reason is that you don't want to round too much. Certainly you don't want to round that to like 13 or something stupid like that. Right? So carry a bunch of digits. What can I do with that time? Right? And then I want to be careful about this side here. The formula is x is VIT plus 1/2 AT squared. But what is 1/2 AT squared if the acceleration is 0? It's 0. So this formula, because I had kids using this thing like this without the 1/2 AT squared on this side, you can't do that.